So hi everyone, let's start our webinar. Thanks for everyone coming and joining us today. Today we will have Dr. Sarah Kaiser, if I read correctly. Thank you very much to accept our invitation. Dr. Sarah is, I think, also quite popular. She already has some YouTube channels and doing some lectures and I think some other stuff. She has some written books on popular topics. Recently, she also joined the Unitary Fund. And today, she is a guest from Unitary Fund for us. So thanks her to accepting our invitation. And this is our 6th Q webinar, and we are very happy to have you. So today, our moderators will be Özlem and Maxim. They are also from QWorld. I will make very short introduction about QWorld. We have nice news about us. And then I will give stage to Sarah, and then our moderators will take care of questions. We have already a lot of in advance questions, so we expect the question answer session can take maybe 20-30 minutes. So each QWorld event has a code of conduct by default. So we are here to talk about quantum science and technology, and just try to stick to this plan. In this line, share our interest and opinions. Also, please don't record this meeting or broadcast this meeting because you didn't ask from the other people. And you can also communicate with us and our moderators writing your comments. So you can write your comments in YouTube, or you can write your comments in the Zoom meeting. This is our motto as a QWorld, like creating opportunities for every potential interested person. And for this direction, we also have a nice news. QWorld officially announced itself 1 year ago. Like we are a community now, and we want to grow. And after 1 year, we also became legal. From now on, we are also a non-profit organization. So we will be able, for example, to get donation from now on, and also we will have sign contracts with the sponsors, and anyone who just support us legally, we can also communicate with them. And for this formation, we also would like to thank Unitary Fund because they also give us a grant exactly for our legal formation. And I also would like to thank to Unitary Fund once more. 1 year ago, they also gave us another grant for doing our workshops, hackathons, and it was really big help. And now they make a very nice help, thanks to them. And this Q webinar is also part of our first global quantum programming workshop. We just started today, and we are very excited. We thank to all the applicants and participants. We received applications from 72 countries, and we have more than 700 participants. And we also put their logos here, and hopefully these numbers will increase in our upcoming events. So now I will give stage to Sarah. Thank you very much again, Sarah, and please.
Yeah, let me go to speaker view here and switch to, yeah, you may have to, I share everything through my webcam, so you may have to click on my picture to maximize it. I'm not sure if I can force you to go full screen from my side. But yeah, thank you again for inviting me, and I'm super excited to be here sharing with you kind of my experiences, kind of coming through the quantum information field to kind of software development stuff, and what I'm really passionate about. So, and as Abu mentioned, yeah, I currently, I'm here on behalf of Unitary Fund. So let me, sweet. So, oh, all right, it's gonna stay. Also, I'm trying to persuade my dog to stop pacing around in the room. Yeah, so as mentioned, my name is Dr. Sarah Kaiser. I do a lot of stuff online and in real life. So I do a lot of Twitch streaming. I write books. The books are usually about quantum stuff, but not always. Sometimes they're for younger crowds. And yeah, I live in Seattle, so I also really like spending some time like kind of outside doing hikes. And we recently just got an older boat that we're trying to restore from the 70s. So that's basically what you'll find me spending my time, both for work and for fun on. So how did I actually get here though? I'm also going to adjust this because I realize my overlay here blocks some of the words. Oops. Okay, so yeah, how did I get here? Let's go to the next slide. Probably like many of you here, I did go to undergrad, but I studied math and physics at the time because I didn't really know what computer science was. I thought it was just like really nerdy people, and that was I wasn't sure if that was me, but I liked both math and physics, and I couldn't really decide whether I liked doing theory or experiment better. So I did a lot of undergraduate research internships, which I found to be really helpful. So if you're a student, really at any stage, definitely look for internships, because I think those were super helpful in helping me figure out which way I wanted to go with these things. Basically, I learned that I knew I liked lasers. And also, I'm getting a laser cutter next week, so the maker spaces are closed here for COVID, so I finally broke down and decided to just buy a laser cutter for my house. But yeah, I really like lasers, and I wanted to go to grad school for kind of something optics and quantum computing related, because the reason I liked quantum computing was because the math was easier. I liked doing matrix math and like linear algebra stuff. But that didn't exactly, kind of like many things in life, it didn't really work out the way I'd hoped. I didn't do super well on my GREs the first time around, and I didn't get into any grad schools. It took me a really long time to kind of process that, and I felt really bad, but I knew that I actually had the skills to do this. So I decided to kind of get a job and save up and take the GREs again the next year. In case you're not familiar, the GREs are basically like standardized exams that the US has for grad school. They're obviously not super standard, and yeah, I don't think they're super good at actually evaluating the things that you need to be a good grad student. But anyway, so I got a job as a software developer actually working on Wolfram Mathematica, which at the time was a software package that I had used a lot in undergrad, and honestly was my first programming language. So I was like, hey, this is a skill that I have. I'm going to go see if I can make some money with that. So that worked. I saved up, I studied again, I took the GREs, and then I ended up going to grad school, not in the US, where it didn't matter about the GREs anyway. I did do better the second time though. But yeah, so then I went to grad school at the Institute for Quantum Computing in the University of Waterloo, and found some really cool projects to work on there. I studied quantum key distribution. So that's kind of like it's not quite quantum computing, like working on computers directly, but it's using spin-off technologies to kind of improve security. And I found it really fun because I could use those high-powered lasers, and I could, you know, I could actually work on hardware, because what I learned was I like doing hardware stuff mainly, but I also like coding. I like kind of a good mix of the two. But it wasn't necessarily all happy all the time, because the university there really struggled with supporting me and many other students there with issues of harassment and discrimination. So that's why you will see some of my recommendations later will be kind of relevant to that, and one of the reasons why I think QWorld is such a cool organization. So after grad school, I ended up doing a postdoc in Australia. It was really fun to kind of move literally to the other side of the planet, and I worked on nitrogen vacancy centers for nanodiamonds, in nanodiamonds, so we could use those for medical sensing and stuff like that. It was a cool project, but one of the issues was our lab got flooded within like 2 weeks of me starting there and destroyed all of our equipment, which was just like super, super bad luck. And so I ended up spending most of my postdoc actually working on open source quantum software. So after that postdoc, I kind of was like, hey, this is actually something I'm maybe more interested in right now. So I decided to kind of pursue the software dev stuff again. And also move to Seattle. So I knew I wanted to kind of get better at my actual software development skills. Being a physicist, I didn't really have much training in how to do that. You can always copy and paste from Stack Overflow and make stuff work, but I wanted to kind of improve my skills in that area. So I started seeking out meetup groups in kind of the Seattle area. And what I learned was that these were really awesome communities to be a part of. Like, I really, really enjoyed going to like Pi Ladies meetups, R Ladies, people, women who code, and all of these groups like were super open and welcoming, and they really helped me kind of improve those skills. And I started kind of, as I attended these meetup groups, I started giving more talks, and actually eventually was convinced to start streaming on Twitch, which streaming in this case, actually writing code live, which initially just terrified me because I was like, I'm already really nervous when I write code. Why do I want more people watching me do this? But it turns out it was a really kind of good jumping off point, and now I'm really happy to make any mistake in front of anyone. So yeah, how can we, so now that you know a little bit kind of about where I'm coming from and my journey from academia to software development, how can we actually go about learning how to write quantum software or do quantum development together? As I'm sure many folks here know, there are a lot of challenges associated with this. Quantum computing is a pretty interdisciplinary field. So when you have learning materials, sometimes it's geared for computer science background, sometimes it's from the chemistry side or the physics side. There, depending on what you're working on, can also be just a lot of those concepts just mushed together. And it's really hard to get, to find kind of good resources to help you learn, especially if you're not in a formal like academic course for it. And kind of a pro and con, there are a ton of options for languages and platforms and tools that you can use now, which honestly is one of the reasons why I'm still just super, super excited about quantum software in general, because our ecosystem is growing. But it also has then, as we grow, it has the downside of there are a lot of choices, and sometimes having too many choices can, I freeze up and I'm like, but I don't know what to do. So, being able to explore and understand what the differences between all of those options are takes some time. So we have our classical computers now. Obviously, there are tons of folks working on hardware and stuff like that. I'm not going to be talking too much about that, but with what software tools we have now, what can we do to actually learn more about quantum computers, write software for quantum computers, and actually just use this technology? This is basically where open source comes in. And just to kind of help define what I mean by that, open source software is a kind of a broad category of software that can be freely used, accessed, shared, by literally anyone. Usually it's posted free online on GitHub, GitLab, Bitbucket, services like that. And there will usually be a license associated with it. So definitely it's good to understand what the differences are for those licenses. But in general, like you have this category of open source software, and then there are also open source communities, which are basically everything but the code, but still associated with these projects. So like the licenses, any processes or governance, how do you fund social media accounts, pretty much all the other infrastructure that goes around maintaining a project. You know, we just saw in the announcements for QWorld, like they were talking about kind of some of their processes and governance and funding and stuff like that. So, you know, these are pretty common traits or experiences for open source communities, and yeah, we can actually leverage that here in our quantum realm. So one of the things that I find really, really cool about quantum is that we've been intentional about making the community, especially the software community, open. So this is kind of a timeline of open source software projects in quantum, starting, you know, in the mid 90s with Q-tip. Can I move my? Yeah, we'll do this. Starting with like Q-tip all the way over here. And then kind of as we transition to a lot of the early industry sorts of offerings, whether it's Qiskit, Q-sharp, PyQuil, stuff like that, there was a big push to make those open source. And, you know, basically for the reason, this is how we can encourage growth and building new tools for a field that, you know, it's not so big. And what we really want is more contributions and more people helping us build it. So, you know, it makes it hard to do that if you're siloing everything in, you know, company protected sorts of code bases. So yeah, there was a lot of kind of early intention to make things open source. And now, like, I think because of that, and what we've seen is just this huge explosion of tons of different open source projects for quantum software. Also, so please put in a question for the audience at your convenience. If you've worked on an open source quantum project, whether it's a contribution to the project or maybe you use one like Q-tip or something like that, please put it in the chat because I'd love to see what projects y'all are working on. But yeah, so we have this kind of great starting point here of a bunch of open source platforms and tools that we can build from. So this is kind of where the Unitary Fund comes in. We are a nonprofit organization, not unlike QWorld, where we help kind of foster quantum technology. Here, let me read the tagline. Creating a quantum technology ecosystem that benefits the most people. So, you know, we aren't committed to any particular technology, tool, language, whatever. We want the most tools and platforms available to the most people. So we kind of have two main things that we do. We run a microgrant program. So that basically means we're giving $4,000 US to open quantum technology projects that can be developing new tools or making contributions to existing ones, making games, or things like QWorld, where it's community organizations that are helping to support the quantum community more broadly. And so that's thanks to the support of a lot of different kind of the industry sponsors. And the other kind of main project that we do
We cannot hear you right now.
Okay, can you hear me again?
Yes.
Okay. Seems like just the software crashed on my headset. Cool. Anyway, so the other thing that we do at Unitary Fund is Unitary Labs, where basically we do some open source and build some open source quantum tools as well. Usually with that, you know, we're not trying to compete with anything. We're really trying to find places where there aren't projects or there might be a need, and work on building the projects kind of in those gaps. And so one of the projects that we're currently working on building is called MITIC, which is an open source compiler for error, like it adds error mitigation to your circuits. So I'll talk a little bit more than in a minute. And one of the other big things we do as Unitary Labs is help support QTIP. So QTIP is probably one of the, sorry, the subtitles seem to, microphone issues. I'm going to just restart the slideshow here real quick. Okay. There we go. One sec. Okay, there we go. I think the subtitles are back. It only destroyed all of my other windows. Anyway, where did it go? Yes, here, please. Excellent. Okay. So yeah, we help support QTIP as well. So with respect to the microgrant program, so far we've funded 30 projects with about 90K investment, and that has funded projects in 14 countries, 4 continents, and generated 8 publications. We've actually had one of the projects spin off into a venture-funded startup. We've got over 12 new open source libraries, and actually 7 new people who are full-time working in quantum software from getting one of these micro grants. And then, yeah, the repos for the projects that we fund also have quite a few stars and forks as well. But yeah, so to give you kind of a sense of some of the projects that get funded here. Here's just kind of 3 sample ones. So we funded Crack, which is basically one of the fastest quantum simulators, period. And it's a really neat open source framework that has like GPU acceleration and everything built in. We also helped fund QNetSim, which was to basically help with quantum networking protocols and kind of build up a framework for that. And then I think it's supposed to be Oslo, but with a Q. I don't know how we pronounce that. But again, another kind of compiler intermediary tool that helps lay out your circuits for different physical, like hardware devices that you might want to run your code on. I see a question from Michael, which is, how does the open source ecosystem work for freelance devs versus sponsors? Devs get paid for hot project contributions, while sponsors get to set the field of R&D that would benefit them the most for ROI long term. Yeah, that's kind of interesting. I mean, like, in classical computing, for open source projects, often companies will pay full-time devs to work on the open source. Everything that the person is doing just goes to the open source project. Here, like, I don't know of too many freelance open source developers. I think I might be one of the few, but yeah, so far, like, when we sponsor projects, we're not necessarily saying this is the direction you have to go with something. Like, we can offer help and guidance if people, you know, kind of want a bigger team to bounce ideas off of, but when we sponsor projects and stuff, they submit an application for what they want to do, and it's usually just like green light, here's your money, go do the cool thing. But I think that is an interesting question. Like how is that going to kind of work out in the long run? Which model, whether it, you know, being paying full-time devs or like sponsoring sorts of projects will win out. Hopefully that answers your question. So, and it's a very good question. So yeah, to maybe also expand here a little bit more on Mythic, I also got to actually make a change of slide. So I mentioned Mythic is a project where the Unitary Labs is building. But basically, the sell is quantum computers have errors, and Mythic is a cross-platform compiler that will help you make your programs robust to these errors. So basically, if you have a circuit you want to run on hardware, basically you would pass that circuit to Mythic instead, and Mythic would take care of running it on the hardware. And what we can do kind of in the middle, being in the middle here, is use different error mitigation techniques. So that's not full error correction. So you can run your circuit as is on one end and just deal with the errors. Or you can try and like refactor your entire algorithm and get a bunch of overhead to do fully like fault tolerant quantum computing. But as I mentioned, that has a huge overhead and often is not tenable to do on current hardware. So error mitigation sits kind of in this nice middle zone of like, we don't have to we add a little bit of overhead, but not a lot, to help make it easier to run on near-term hardware. So yeah, basically it's a Python package that works with Circ and Qiskit and PyQuil. You can check out more about the project. I forgot to put the link on the slide. It's just unitary.fund/Mythic. I will put it in the chat here. unitary.fund/Mythic. So yeah, definitely. And we actually just this week or last 2 weeks since we started doing, we do open community calls when we like to pick what we're going to work on next and stuff. So that's all in the open and you can kind of see how we work on it. So what's next for the Unitary Fund? Basically, we will plan to offer fellowships, year-long 50K fellowships for doing open quantum science. And this is, I think, a really, really neat idea where basically we can kind of, you know, it's really flexible. People don't have to, software dev can be done remotely. So, you know, we can support folks anywhere in the world with this. You know, it provides another sort of track or option. Like most of the people I know, obviously myself included, went through go through school, get a PhD, now go do something else, do a postdoc. You know, that's kind of the way, but that really isn't the only way. And at this point probably is, depending on what you want to do, may not be the most efficient way. So yeah, I think it's a really great option for folks who want to, you know, be paid and actually get to work on some cool stuff like this. So yeah, things you can do to help are, you can spread the word, become a supporter. So if your institution is interested in financially supporting, we also have mentors and basically advisors who kind of review all of our applications and help kind of guide some of the projects if folks want. Or you can contribute code to any of the projects that we support. So to kind of wrap up with my last section here, what can you or I or any of us personally do to help grow our open source quantum community? I got 3 things here. So first is to import or include open source software best practices when we're working on quantum stuff. So there are a ton of really good resources for these online. I put some links here. I'll make sure to put them in the chat, and I'll also have these slides up on my webpage after we're done here. But to kind of summarize some of the top ones, and I love that QWorld has pretty much all of these. Codes of conduct. If you were running an event, a webinar, even just starting a new repo, put a code of conduct in it. It's really easy to get templates for. You don't have to do any thinking, but it makes it clear to folks who want to contribute to your project, that they're welcome, and that behavior that might discriminate or harass is not welcome here. You can ask for pronouns. I always try to remember to put them in my email signatures, because that can help normalize it for folks who maybe have people assume the wrong pronouns for them. Accessibility is another big one. You can see here, I'm trying a slightly different way of getting captions for my talks here through PowerPoint. You can just literally turn this on in PowerPoint or Google Slides now. It makes it really easy for folks later then if there are audio issues, or maybe they're a little bit hard of hearing. But this is one example of many, many different accessibility things that you can add to your events or spaces. So definitely some of the links I had on the previous slide have great lists for that stuff. And then find and support diverse members and contributions. So whether that's having scholarships for people from diverse backgrounds to contribute to your projects, or whether that's mentorship programs to help help people kind of find mentors and get some guidance when they're trying to learn quantum computing, or have a particular research goal in mind. That can be, having had some really good mentors myself, that is super, super important, I think. If we want to really encourage everyone to kind of be here and learn quantum and contribute. And did I mess up the number? Oh no, this is number 2. Find or create open source communities in quantum computing. We pretty much, y'all got this covered. You got QWorld. There are tons of communities though for kind of, different variants, different locations. Definitely find the right ones for you, and, that will be really helpful for you in your kind of quantum journey. And I do think we need to really pay attention to how the culture in quantum research and industry influences our communities. There can be some really toxic sorts of behaviors or personalities that, as we're trying to build these communities, we want everyone to be welcome here. And so I think it's important to be kind of mindful of some of those toxic patterns to make sure we don't include them. And 3, contribute to open source projects. That one is probably obvious, but yeah, find a project that you like and file a bug. That's contributing. You don't have to write a thesis and contribute a new feature or something like that. Even just dropping a comment saying, hey, this paragraph here in the docs, I didn't really understand. And if you need ideas for that, the Quantum Open Source Foundation has a huge list of projects that are all I think it's pretty close to exhaustive. I won't claim it is entirely exhaustive, but it's a pretty big list. So you can look through there by language and stuff like that to find projects that might be interesting to you. And yeah, this is the very first time I contributed to open source was actually only 3 years ago. So I did it at a conference and had somebody help me because I was really nervous because it seems really scary to be this is going to be public for everyone to see. What if I messed it up? You don't have to be so anxious. I have made plenty of mistakes and if you build good communities, people aren't going to come yell at you and they'll actually help you. So yeah, in summary, communities of people who are going to be making our quantum technologies, and let's make it welcoming and safe for everybody. Yeah, so thank you very much. And yeah, if you want to connect with me, you can check out, I'm on Twitch, Discord, Twitter, Reddit, all of the places. You can find links to those on my website. And if you want to connect with me via Unitary Fund, you can send me an email there. And if you're interested in supporting or mentoring or anything like that. But yeah, thank you so much.
Thank you very much for nice talk, Sarah. It was really encouraging. And I hope hope participants also enjoyed and got the idea about exactly the place of open source community in quantum computing. It's really exciting to see that while having quantum computation just emerging, that we already have such approaches and tools available for us. So indeed,
Yeah,
it can
sure.
grow in much healthier and more beneficial manner, I guess, for all the society.
Yeah.
Yes, participants have asked some questions in advance. So are you ready to answer them?
Yeah. Shoot. Here, I'll
and the
switch
first
it
one
back
is
to...
from Yajas Asapana from India. Are there any hardware opportunities for students having photonics background?
Ooh, like, so I'm thinking in terms of like internships or sorts of research projects. As I mentioned at the beginning, like research internships, like as you're a student, whether it's undergrad or grad school, because there's so much in quantum industry now, like a lot of those companies offer internships. So like I believe Zapata does optical quantum computing stuff, so that might be of interest. And I know that they have at least some forms of internship programs. But yeah, hardware is kind of tricky for or at least is a little bit harder for open source stuff. We know classical computing has a huge open source hardware community, but when most of our quantum hardware is like either extremely expensive or really, really hard to make, it's kind of hard, you know, for people to kind of get involved there. But the nice thing, and one of the reasons why I really like optics, is all of the stuff we need to do for like quantum optics is all commercially available now. Like I don't need to go, I can literally buy off of eBay or Alibaba like a bunch of laser diodes, attenuate them down, and have qubits. So yeah, I think like I know Microsoft just announced their hardware internships, but they're most likely going to be more superconducting stuff. Probably another good resource for that is a lot of the communities, whether it's I'm sure probably QWorld has some similar stuff, but like the Quantum Open Source Foundation and Unitary Fund, like we always post internships or job opportunities as we see from different companies. So look at their Discords and Slack and you might find some good stuff that way.
Nice, thank you. The next question is from Virat Kumar Katari, also from India. Yeah, actually, he wants to make a further career in quantum computer and
yeah. I mean, one of the things that this is a fairly common question that I get, and what I'm very happy to be able to answer now is it doesn't require you to go get a PhD. Like, you know, historically, that's just, people just assume if you're working on quantum computing, yep, you probably went and got at least a master's, maybe a PhD, you were an academic, and yeah, that's not necessary anymore. You know, you can, in the same ways that, you know, I can write code for graphics cards, but really what I'm doing is I'm using Python to generate, you know, I'm using a Python tool that I know how to use that generates code that accelerates my Python code on a GPU. You know, people who have basic just classical software dev backgrounds can get into quantum. So it sounds like this person is familiar with artificial intelligence.
yeah.
So that's a huge kickstart, because most of, just like artificial intelligence, a lot of that is going to be, you know, neural networks and basically linear algebra, where you're kind of keeping track of weights and multiplying everything. That's the good news is that's a lot of what quantum computing is. It's linear algebra asterisk with a little bit of nonlinearity. So, you know, you've got a lot of the good math skills and probably the computer science skills to kind of build off of. Plus, there's quantum machine learning is a whole field of research and of interest that, you know, I don't know. I find it very interesting. We have some good hope that it will be, you know, something that we can really use and leverage, but there are some trade-offs. So like one of the projects that my first, I think the first open source project that I made like by myself actually was one funded by Unitary Fund, and it was a library for quantum memory in Q#, which was basically derived from machine learning applications. And so, yeah, I think there's a lot of really interesting opportunities there if you have like artificial intelligence or ML background to kind of get into quantum computing there.
Nice to hear that.
Mm-hmm.
The next question is from Abdullah from Singapore, and he's final semester student, and he has to do a thesis project. Want to do on quantum computing, but couldn't decide the topic. And so the question could be, what could be the nice topic to be able to publish paper in the future?
That's a good question. and you know, there's ideas that I think generally people find interesting, and then there's the academic publishing system, which is always kind of a quagmire to navigate. Before I get to the paper topic, I would definitely suggest submitting to Quantum. So there's literally a journal, it's just called Quantum, but it's specifically an archive, like open source journal. So the fees are very low. The review, like the editors are fairly inclusive. So that's I think a good option for places to publish, especially quantum software projects, because unfortunately most of the kind of larger journals have not really kind of accepted quantum software as being like a research topic. And so it's kind of harder to take a software project and get that published as a paper. Not impossible, but just harder. Interesting topics though. Well, I mentioned just a minute ago, quantum memory, or QRAM, is kind of a really I personally find very interesting, because I think it's what will make or break most quantum machine learning kind of algorithms. Because right now we have these algorithms that look like we have a speed up on a quantum computer for machine learning stuff, but we haven't quite counted all the costs for like what we actually need to run the algorithm. And so unfortunately, keeping bunches, like trying to have your weights, say, for your neural network stored on your quantum computer, or trying to like transfer them back and forth between classical memory is pretty expensive. And so like QRAMs would be a pretty interesting topic potentially, or at least one I find interesting. Another one that I also find pretty interesting right now is quantum intermediate representations. So when we're writing all of these software tools, you know, there's tons of different programming languages, you know, whether it's an entirely brand new language like Q# for quantum computing, or Python packages like Qiskit or Circ or whatnot. You know, ideally these all could work together and you could write in whatever language you like and run on whatever machines and devices you like. And we sometimes kind of get that in classical computing, but usually if we have some sort of common interface or intermediate representation for your code or programs, we have tons of examples again of this in classical computing. And so I've been working with some folks both at the Unitary Fund and the mentorship program for the Quantum Open Source Foundation that just trying to do some research on this. So like there's OpenChasm, there's QIR from the Q# folks, there's Quill, you know, just trying to like survey those, figure like pros, cons, and then, you know, what tools can we actually get to connect these. And I don't know, I feel like trying to figure out what are the necessary and sufficient conditions for that intermediate layer is a really interesting question, because it has to represent both our quantum like programs as well as classical logic. So that's kind of the holy grail there. So yeah, those are two ideas.
So there is a lot of work.
Yeah, and that is not an exhaustive list. Those are just topics that I personally find interesting. Again, check out your community forums, whether it's you know, Unitary Fund, like tons of, like just say, hey, what are people working on? What's interesting? And you might find some more ideas that way.
The next question is from Togan Tlimakov Yusuf from Turkey. So he asks about the internship opportunities for international undergraduate students in this field.
Yeah, I think we've talked a little bit about this, but I mean, thanks to COVID, pretty much everything is going remote, which I think does make it a lot easier for international students. So you don't actually have to relocate to participate. Yeah, and tons of companies in quantum computing, whether it's IBM or Microsoft or Rigetti, like almost all of them have some sort of internships programs. They don't really go on any sort of schedule, so there isn't like, generally they're kind of focused around summer because that's when like undergraduate students would have off. But I know Microsoft just posted a bunch this week actually. So but yeah, you'll often find, for the most part, those will probably be software related, but often can also be like a research topic. So I know some of the ones at Microsoft are like working in collaboration with their researchers. So you'll actually be writing papers and getting, actual academic papers. Some of them are developing open source software tools, and those may actually also have papers and citations, but it kind of depends on whether you're more interested in doing like software focused things or actual like research focused things. There are also hardware internships, but I haven't seen too many of those that are remote possible. So yeah, that basically just comes down to whether the company can get visas and stuff for that.
Noma from Fundisi, South Africa, is asking the following question. Is it possible for someone to work in quantum industry without engineering? In other words, how much marginalization is in quantum industry?
I don't think there is any specific background necessarily that you have to be able to work in quantum tech stuff. Like, I've met people who have literally no quantum background whatsoever. Maybe they're software devs, maybe one of them actually just worked on CI/CD or continuous integration and deployment, like cloud service stuff. And they're one of our biggest contributors for Q# community. Like, so, I don't think, just like you don't have to have like a degree to be a software developer, I don't think you need to have a degree or specific, even engineering specific background to be able to contribute. Yeah, I know like most of Microsoft's internal teams that are like not the specific research team, they're all classical software devs. So like programming skills will definitely be a bonus if you happen to have those. But they're not necessary. I find having those programming skills helpful, because then when I don't understand something, or like I can't figure out how to do the math to work it out, I can get on Q-tip and I can just ask the computer to work it out for me. So that's my like double check. That's my backup, my homework partner, if you will. So those skills can be really helpful there when you're learning and getting a job, honestly.
This next question is from Braulia Atavala from Ecuador, and he's asking for PhD in quantum machine learning scholarships or similar research programs that would be accessible for non-EU applicants. Maybe you know some.
I know, I'm trying to remember where Maria Schold went. She was in the University of Johannesburg for a long time. I think there definitely are some. I honestly don't know off the top of my head. Sorry, but definitely this is another good one to like check out the community forums, like Facebook groups, stuff like that. Please feel free to follow up with me, and I can do a little bit of research and try to find some. But yeah, I don't know off the top of my head. Sorry.
yeah, people may need to do some research. Also, I guess there may appear some new ones. Quantum machine learning is indeed emerging.
For sure. And so like most like the scholarships and stuff, that like what you'd probably be looking for is like a someone who's the leader of a research group advertising new student positions or something like that. Sometimes I have seen some industry positions for that, but especially if they're looking for a PhD, I'm assuming they're interested in academic programs. But I know there are definitely like Singapore is another big I think it's CQT is their institute. They have a lot of stuff there, including quantum machine learning stuff. So yeah, but I'm not entirely sure the details for the non-EU applicant stuff.
Mm-hmm. The next question is from other direction. So how will the open source quantum software community will make commercial application acceptance easy?
Well, I think it'll make it easy from the standpoint that companies that, you know, say I'm a company that maybe I work in oil and gas or something like that, and I have, you know, a problem that I know I can solve with a quantum computer. Hypothetically, I would hire a bunch of engineers. They would write a bunch of, you know, our internal software. We'd have to write everything from scratch, probably work out partnerships with, you know, IBM or Microsoft or whoever we're working with. And do everything kind of separate ourselves. And you know, any other company is going to have to repeat that effort. What having a healthy and good open source community gets us is everyone basically can start much farther along in the process. So you know, they can literally just write their quantum program in, say, Q# and not have to build up all of the infrastructure and the compiler and to get it, you know, to connect it to hardware. You know, Amazon, Microsoft, and Google, and I think maybe also Google and IBM all have the cloud services for quantum hardware, right? So, and those cloud services, so that basically means your quantum computer is just available on the cloud and you can send your program to it and you don't have to, like, that's all you have to do and you get your answer back. Like none of that would be possible without open source quantum software tools, in addition to just general computing open source tools. So networking protocols or Electron, like making GUIs for things like Electron is, yeah. I think we really don't realize how much our like actual computer or application life on our devices is dependent on open source projects.
Yes, the next question is from Agarwal from India. And his question is, how does making open source quantum community can help in developing the field? I think if you have any additional comments.
Yeah, that's pretty much the same question. The only thing I think I'd add is it really helps like grow the field, both from an industry standpoint, which was what I was mostly talking about before, but also from a research side. I cannot count how, as a researcher, how many times I had to rewrite the same thing effectively, you know, for different groups or different projects, because we really didn't do a good job of sharing like the code and the work that we've already, like we wrote the papers, but often those papers don't include the source or don't include, you know, the actual data that went into it. And so doing open science more broadly, you know, which is kind of based on the same same principles as open source software stuff, I think will really help us make better and faster progress in the field.
Mm-hmm. And speaking about the progress, the next question is from Nilüfer Oslan from Turkey. And he asks, like, quantum computers can decrease the security of classical systems. And so whether there is drawback of open source quantum world.
Yeah.
Whether it's getting dangerous.
I think the premise there is a bit of a misnomer. I don't think the security level is really, like, quantum computers, this is one of my biggest pet peeves, having done my PhD specifically in quantum crypto stuff. Quantum computers aren't going to destroy all of our security as we know it. Like, yes, we know about Shor's algorithm, which would allow us to factor large numbers that are related to crypto faster, but it's not necessarily decreasing our security level, because the likelihood we get a quantum computer that can run Shor's algorithm is, honestly, if I see one before I die, I'll be real happy. But I've got another good, hopefully 30, 40 years here. So I don't see any drawbacks to being open. And I think we've seen with other technologies like AI and machine learning, or like different robotics fields, it really does help to be open at the beginning, because then we can all like work on progress together instead of re-implementing everything in isolation. So yeah, I don't see any downsides.
The next questions are about the possibilities to contribute. And first is about the beginners, so how they could contribute, and also maybe you could suggest some beginner-friendly open source quantum projects.
Yeah, that is a tricky one, I think, sometimes, just because the more specific the project is, like in a quantum field, like if, you know, even MITIC, like error mitigation for specific languages and stuff, it can be sometimes hard to like find ways to contribute. But so actually, I do think MITIC is a pretty good beginner-friendly repo. But what you'll find on most open source projects is when you look at, I can even like pull it up here. Let's see, GitHub. Oh, never mind, you're screen sharing. When you look at like a project, there are often issues, and a lot of times you'll find projects will tag issues as good first issue. So that's usually like if there's something new I want to contribute to, I will just check to find good first issues. And we try to like at the Unitary Fund encourage all of our projects that we fund to tag issues to make it easier for people to kind of contribute. I think QTIP is probably like, just because that is kind of a basic quantum toolkit, especially if you know Python. That's a great project. Q# has a lot of really good like community support. They tag everything, good first issues and stuff. So those I think would be some of the ones that I'd suggest.
Okay, and the next question about the contribution. Yes, it sounds interesting. Like, what are the different ways that we can contribute, and along with the percentage of how many physicists, computer scientists, and mathematicians could be involved? Maybe you know the best recipe of proportions.
Yeah. I mean, so like, there's kind of like three main ways that I see contributions kind of break down. You can literally write code, which is obviously always good. But there are two other really important things, which are improving documentation or writing documentation for a project, and like filing bugs, issues, double checking other people's work, stuff like that. Those are all like really important and really like almost, they are equally important sort of contributions. So, you know, someone who files a bunch of bugs on my repo, I don't get mad at them. I'm like, yay, thank you. Now I have things I can fix. So to the second part of the question, what percentage of physics, CS, and math is involved in it? It really can, I think that highly depends on the project that you're contributing to. So like, you know, we had someone recently contribute to MITIC, kind of like a new statistical analysis tool. So that was kind of, you know, probably equal parts of all three of those. So like they had to write the Python code, they had to know a little bit of statistics, and it was for a physical, like it was for quantum computing. So they had to understand the, you know, the bracket notation to work out what the stats should be. But, you know, sometimes they can be just fixing the linter or some tests, which would be purely CS and have nothing to do with the other two. Or like I've been trying to improve some Bayesian analysis on MITIC, and that's pretty much just physics, a little bit of math, to even just work out what we want to do with that. So yeah, I don't think there's any strict formula to how much of each needs to go into contributions.
And the next question is about the platforms. So we have for machine learning Kaggle, for example, and what tools can help for open source quantum community?
So good news is there is a stack exchange. So I think Kaggle, if I understand correctly, is like a competition platform. Is that right? Where they're like puzzles and stuff like that?
People also put their codes, like it's like an open source. It's like GitHub kind of.
Oh, okay. Gotcha. Yeah, I've seen people talking about it on the internet, but I have not used it myself. But yeah, like, so yeah, there's a quantum computing Stack Overflow. So that's like where you can kind of ask questions. I know that some of the different coding competition sites will periodically run competitions like for quantum computing stuff. Like I know Q# does that quite frequently with, I think, Code Forces. But yeah, I'd love to see more ideas or suggestions or places that are hosting that. Like, I don't know of anything like exactly the same as Kaggle, but I think different pieces of it are probably represented at like the Quantum Open Source Foundation, GitHub itself, stuff like that. That's a great question, though.
The next question is about why we don't have a full stack for quantum software. In other words, whether there are challenges in high-level abstract quantum programming software.
Aha, that's a good question. The answer I can give you is there is, and it's Q#. So I think Moen correctly observes that a lot of our software tools right now are pretty low level. You know, thinking in terms of classical computing, it's like the difference between writing in BASIC or assembly versus JavaScript. Like JavaScript is obviously a much higher level language. Assembly or, you know, even machine code is like very, very close to hardware. And a lot of our quantum software tools have traditionally been pretty close to that hardware level because, well, that's what we need. We don't have that right now. So there are some attempts or approaches at getting that higher level or abstract sort of approaches, and Q# is one of them. So it's really an algorithms focused language. So you see your paper, you have your quantum algorithm that you want to code up. Q# is really designed to be a kind of like a helpful / language that's just designed for doing that. And it is full stack. Like you can, yeah, I wasn't quite sure about that comment, but there are lots of tools and platforms that will go, you know, from your code all the way to hardware and back through the cloud.
Okay, now I will continue. There's a question about like how to use quantum computing in solving power analysis problems. And like, is it possible to integrate quantum computing in microgrids? So this is from Abu Said from Australia and also Bangladesh.
That's a great question. I don't really, there are plenty of applications and stuff that I just don't know that much about. There could be. I definitely have, I think I've seen papers kind of along those lines, but in terms of how long it might start taking before people are utilizing that, I think really that's the same question then as like how long before we get enough qubits to run, you know, larger quantum programs and stuff like that, which varies depending on who you ask. I would hope though, like if that is an application that, you know, does have some easy sorts of or clear directions, probably in the next 5 to 10 years. I don't know.
And a question from Akif from Turkey, like about quantum cryptography. So he asks like whether should we wait until we have our own quantum computers to be able to use those systems, or will it be necessary without the hardware before like the hardware stuff comes?
That's a great question. And my answer is definitely you don't have to wait for hardware. That's kind of what I find really cool and exciting about doing like quantum software in general, but open source software even more so, is like we can actually build we can build compilers, we can build backends, we can, you know, write about this intermediate and build things around this intermediary representation. There isn't really anything stopping us except from running those larger programs. We can simulate small examples to validate our programs and build up the infrastructure for arbitrarily large quantum computers. Nothing is stopping us on that. We just can't sometimes run the actual program then at the end if we don't have enough hardware. But I think there's a lot for us to learn and work out and understand about what that kind of stack looks like for the larger systems, even if we don't have the hardware. So yeah, like I don't use hardware almost ever.
By the way, do you have still time? We have some more questions, but
yeah, I have probably another 20 minutes.
Okay, thank you very much. Like there is a general question from Narayan Hanal from Nepal about like what do you think about the future of quantum technology and its impact?
I mean, I'm obviously pretty excited about it, and I think it will be. It will definitely have a big impact on how we move forward. I think it probably is not, you know, a lot of times I see articles and stuff that are like quantum computers are going to replace everything or whatever. And it's like, no, quantum computers, strictly speaking, need classical computers to operate. You know, it's almost a bad, I almost wish we didn't call them quantum computers. I wish we called them quantum like hardware acceleration, or like a, you know, something along the lines of a GPU, QPU maybe, I don't know. But I really think that we're going to see the most interesting near-term impacts on like chemical simulations and stuff like that. So for example, one of the research projects like that Microsoft is working on is trying to understand how plants photosynthesize or convert like light into their energy, because we can't actually copy it as efficiently as they do. And so I think, you know, it's kind of applications like that, which actually don't need a lot of qubits, will get us, you know, kind of some of those near-term benefits. And then as we are able to build hardware bigger, you know, I have no idea what the impacts will be. I think similarly, if you ask people in the 40s and 50s, you know, what the impact of computers was going to be, they wouldn't know about this. Like the fact that, you know, I've got 18 applications here, compositing videos, sending it to you, and, you know, talking to people all over the globe. Like, I don't think they would have imagined that as part of the scope. So I think it's just exciting, and I'm really excited to be a part of it.
It's really hard to imagine what will happen in like even in 5 years.
Exactly. Exactly.
Well, there's a question from Vishal from India, but I guess this question is more to us. So it's like, how will this workshop help us to get a job in quantum computing field? So right now, as we have mentioned, we have a workshop going on. It's just started today. It's about quantum programming, and so basically, it will help you to make like the first step towards learning quantum computing, learning quantum programming. So I think it will be a good start for you. I don't know, maybe Sarah also wants to add something.
Not exactly. I think, you know, I'm really supportive of anyone giving it a shot. You don't have to worry about any sort of necessary background. If you are interested, there are resources that you can use and leverage the communities, you know, connect with people at QWorld, connect with people at Unitary Fund, you know, apply for a micro grant. If you have a cool project idea, like we fund people who have, you know, who are not students, who have no research background, like there are no prerequisites for you to get started. So
now I will move on to questions that were asked in Discord. So this is from Mojume. Can you suggest some small projects to start with learning those software packages you have mentioned? So how can one be familiarized with those software packages?
So usually different packages will have some sort of like getting started or hello world sorts of things in their docs. And those can be helpful. I find personally, like if it's like a kind of a tool, like a programming language or something like that, I really like building simulators. So basically backends that can run your code, because that, like, I know how that should work, right? That's where, you know, I can code up a Hadamard, I can code in my states and stuff like that. So it's kind of somewhere familiar that I can start and say, all right, here's this new software tool. How can I use it to do this task? So, you know, if that's the kind of thing that the tool does, I will usually try to make just a basic simulator to start with. And that's actually one of the things. So the book that I helped write, Learn Quantum Computing with Python and Q#, you actually start by writing a simulator in Python to kind of learn what that interface should look like to quantum hardware, and then learn how to kind of write the Q# programs to leverage that. Other like small projects, I'm actually, this is on my to-do list for this week. I always try to like, in addition to like tagging good first issues, I like making trying to come up with lists of good like entry-level projects. If you look at, here's a good suggestion. Go to qsoft.org. I'll put the link in chat. So the Quantum Open Source Foundation, they have mentorship, like a mentorship program. And they have a list of like what those projects were that people kind of did as very entry-level projects to kind of get started in a ton of different platforms. So that might also be a good place to kind of get project inspiration from. But yeah, we're obviously looking for contributions on Mythic, but there's tons of different projects that are available.
Thank you. There is a question from Moin, and like he asks, why the software such as Qiskit are gate-based softwares, and why don't we have like more abstract software synthesis?
I touched on this a little bit earlier, but there are, Qiskit is not the end all be all of tools. It's definitely very good for what it does, which, as this person notes, it is gate based. But yeah, Q# is kind of the other, at least of ones that I know, kind of the other end of the spectrum, where it's a very high level, very abstract sort of approach to writing quantum programs. So you don't have to figure out what, so a good example of this is like in quantum algorithms, you have this pattern of you need to like prepare a state, then you do some stuff, and then you need to unprepare it, right? So that quantum computing has to be reversible, right? You know, normally you would have to work out what all the adjoints or inverses are for those operations, and you'd have to write all those out separately if you were doing a gate-based thing. In Q#, you can just say within, and you can say the preparation, and Q# will figure out how to reverse everything. Basically, it figures out how to clean up after you, which I think is a very, you know, feels very much more like automated memory management in more modern languages, as opposed to you having to release pointers or release, you know, registers as you use them. So yeah, there are good high-level options as well.
There are two questions from Tanaso Hernandez Yanes. The first one is about like this subtitle tool you were using during the presentation. Like it looks great. And like secondly, what kind of involvement do you think a PhD student could have in terms of the Unitary Fund? And to continue a fellowship seems too tall of an order in terms of the time, but the microgrant sounds like a great starting point.
Yeah. So for the subtitles, it's literally just what's built into PowerPoint. It's actually the first time I was trying using this. There are some other, I have automated subtitles for my Twitch streams and stuff too. So there's, I can put on Discord the link later. for the tool that I use there. But yeah, this is, I know Google Slides also has this built in. So you just find it in the preferences and turn it on, and it will automatically generate those for you. And yeah, we have PhD students all the time get funded microgrant projects. And I think we had one for a while working on MITIC as well. So there are tons of opportunities. Please feel free to reach out if you want to talk about any of those in more detail, or just submit a microgrant application.
Thank you. Here's a question from Lidmula. What do you think about continuous variable quantum computing?
That's a good question. I think I remember in classes I kind of avoided it because it seemed more messy. Like one of the reasons I liked quantum computing was because it was discrete and that I could represent it, as nice matrices. Once you get into continuous variable stuff again, then now you're using integrals and stuff to yeah. But none of that's inherent. I don't know much about it, using it for computing. Like there definitely were some interesting QKD applications where we're using continuous variable systems as opposed to like discrete qubit states. But I think it's interesting. I think I don't know very much about it anymore. So, but yeah, I think that's what I think.
Thank you. And a question from Hermes: is data loader a QRAM alternative for QML?
It would be, but we don't have, no one has come up really with any good way to load or kind of do the IO input output between classical programs and quantum programs. QRAM kind of comes in two flavors. There's like fixed lookup tables. So that'd be basically saying, here's my fixed data. I'm not going to change it as I run the program, but it's classical data that I need access to while running my quantum program. So that's like QROM, read-only memory. And QRAM is like a full, just like you'd have RAM on your computer, but here it's on qubits. And the problem is it's expensive. I mean, both from a literal standpoint and also in terms of number of qubits and operations and stuff. So yeah, if we had an alternative that could load the data and make it available to the quantum program, that'd be great. But basically right now, QRAMs and QROMs are how we know how to do that.
And there are two questions from David. So maybe you have answered the first one, but like how to start studying quantum theory. He says like there are not many PhD programs in Italy, but there are lots of courses and books. So how to start? And secondly, I think he asked like, do the research institutes or companies look for quantum programmers? So like, who is right now looking for quantum programmers or developers?
Tons of places. I get pinged by recruiters on LinkedIn a lot. I mean, obviously because I have quantum stuff on there and there are these listings for quantum developer work, but a lot of big companies, at least in the US, especially like banks, defense research or defense contractors, everybody wants to kind of have at least one or two in-house experts on this because they believe, it's an upcoming technology. So that's kind of where you'll see a lot of those in industry, unless they are a company like IBM, Microsoft, Google, that's like actively developing hardware or software. With respect to the programs in Italy, actually ping us on the Unitary Fund Discord because at least two of our core team members are from Italy, and so they would probably have good answers for you about programs local to there. But yeah.
Thank you. And like we moved on to the YouTube questions, and this is from Vishal Kumar. What are the scope and positions for electrical engineers in quantum world?
So probably most of what you'll find for that are actually like electrical engineering as it relates to building the chips and the hardware, so building qubits. There are a lot of engineering challenges in basically connecting a desktop computer, through all the necessary microwave or, cabling to go into what most technologies need, which is a DIL fridge to be able to be at near absolute zero. So, because that's where the qubits have to live. So it's like, how do you get the data from the qubits at absolute zero out to your device? So there's a lot of interesting electrical engineering challenges there. There are also, yeah, that's probably going to be the major component.
And a question from Abdelillah Haji. What is the relation between big data and quantum computing, if there is any?
I mean, it's interesting. Like, the relationship that I know of is people want quantum computing solutions for big data. As everybody wants solutions to help them process or learn more about big data. But one of the challenges, as we kind of were talking about, is if you have a big data set that you want to operate on, how do you get that? How do you make that available to your quantum computer? And so we're kind of back to this whole I/O problem of classical information being available to your quantum program. And right now, the overheads are too big. Like, until we can kind of find a more efficient algorithm for that, or maybe just a different approach, most any advantage that you might have for like a searching algorithm or something like that on your data is probably going to be blown out by the cost of just getting the data available to your quantum computer.
And I guess this will be our last question. So this is from Zekican Seskir from Q Turkey. What is your estimate for the size of the quantum software developer workforce in 5 to 10 years?
That's a good question. I feel like I'm doing a Fermi problem for school, for like a competition. I don't know. I feel like there would definitely be, order a couple thousand, I would hope, in 5 to 10 years. Like, a lot of these companies that are building the technology, they'll have pretty big teams. And I really do hope that there's kind of more inclusion or acceptance of this in academia as well, because there is so many ways that like software development can help with quantum research. So like building the right tools for research applications, which are not necessarily the same tools as for like a company that might be building a solution. But that would be my aspirational number. I have no idea. I mean, just like most people in general don't really have a clear idea of how quantum computing as a technology will progress, because a lot of it is contingent on, like hardware advances potentially. So yeah, that I hope there will be more of us.
So thank you very much, really, for this presentation, and also for those like question and answer session. We thank again. So do you want to add anything else before we close?
I don't think so, other than please say hi on, I need to get a link to your guys' Discord so I can add that. I thought I was on it already, but I can't seem to find it. But yeah, feel free to ask me questions there, or on the Unitary Fund Discord as well. That's just, I'll put the link in chat. It's just discord.unitary.fund. But yeah, thank you so much, everybody, for hanging out and listening. And hopefully I'll see you on Twitch or on a Discord sometime soon.
So thanks again. I just want to remind that on Thursday we have another Q webinar by Araceli Venegas Gomez, and you can check QWorld's webpage for the registration. So hope to see you also on our next Q webinar. So thanks everyone.
Bye everybody.
Yeah. Thank you very much.